Hello, welcome to AT&T ThreatTraq for November 24th, 2015. We're getting close to the end of the year's guide. So, and we're going to have to work on our predictions for next year. But hey, this program provides network security highlights, discussion, and countermeasures for cyber threats. We're joined today by Manny Ortiz.
Hi.
Welcome, Manny. Matt Kaiser. Welcome, Matt.
How's it going?
And online by Jim Clausing. Hi, Jim.
Hi, guys.
I'm Brian Rexroad, and Matt, like I said, we're going to have to do our predictions for next year pretty soon, so we'll have that coming up. Not in this program, but probably the next one. Nevertheless, in the meantime, I think you have a little bit of a story about how we shouldn't make assumptions about what we're talking to.
This is generally true, yes, but in this specific case, very true. So some interesting research by, I hope I'm pronouncing this right, Hyperka Ma of Tencent's, again, China, I don't know how to pronounce it.
Sanwu?
Sanwu, we'll go with that.
We'll go with Sanwu.
Yeah, let's go with that one.
All right, Sanwu Lab. Research that came out at PACSEC JP about barcodes and barcode security. Now, it's been known for a while that it's possible to use a barcode as an attack vector in systems where if you scan this barcode, it directly tries to interpret it as the input to something. So for example, if I wanted to directly push this into some sort of SQL statement and then the intent would be to put it into the database, you could potentially do SQL injection based on the contents of that barcode. And because it doesn't look like it's anything malicious, because most people can't visually read a barcode, sometimes it can be used as an attack vector.
And more often than not, you would expect that a barcode reader is basically creating a query that would go into some kind of a database that translates that barcode into something tangible, right?
Sure.
Something meaningful.
You'd assume that it would behave as expected.
Yeah.
This is not about exactly that. What this research is about is that there are certain types of barcodes that have data formats that can be interpreted as control codes. Things in ASCII that, if you hold the control button and press S or A, it does a special function. Now, it turns out that some barcode readers are capable of sending these to the system from things like code 128, which is one of the barcode formats. And as it turns out, most barcode readers are treated by the computers they're plugged into as keyboards. So this, anybody who's ever pressed a control code on a keyboard knows if it's, a keyboard, the system will say, oh, somebody tried to type that. So it's possible for certain types of ASCII codes to do things like control O, control P, a limited subset. So in particular applications, that might allow you to open a dialog or print or do something. So those are kind of interesting. The more interesting ones are with ADF, which I believe stands for Advanced Data Formatting, where you can sort of queue up a lot of data to be sent all at once using these control codes. So I say I scan barcode 1 that says begin this session, scan barcode 2, hold down the control key, scan barcode 3, 4, 5, build out a string of things to send, and then and then terminate that session and dump it all at the system. So some very cool demos where they walk up with a boarding pass, scan that, and it pops up a shell on the laptop that it's connected to, using nothing but these commands. And it's kind of neat. So the coolest thing that I found out of this was that you could take that session, instead of printing out 50 barcodes going 1, 2, 3, 4, you put it on an e-paper screen, something like a Kindle or a Nook, and you write a program that does, for 1 second display this barcode, then do the next one, and you just hold the thing under there, and it builds it out for you and does the attack. So that's kind of neat.
So I'm just trying to imagine the look on the customs agent's face when you...
Oh, like if it was on your passport? Can you imagine? Oh, man.
Well, I mean, it's one thing to go into a system where you scan something that you have, but somebody else is looking at the screen of what's actually being scanned. It's a whole nother thing when you go into, let's say, one of those self-service scanning.
Oh man, you mean at the
your local
supermarket?
Yeah.
And you're saying, well, I'd like to buy one of these, boom, and now you've popped the shell on some box somewhere potentially.
Right.
Yeah,
Just
that's a
depending on how the
possibility.
input's used. Yeah,
That's a possibility. So I mean, again, I guess this is a case where perhaps or not fully addressing the interface, making some assumptions about what things are talking to other things, perhaps needs to be addressed a little bit better to make sure that there are controls in there. It's actually, even before the SQL injection, it's kind of a similar thing. It's there's information being transferred that perhaps wasn't originally intended in the first place. And I think one of the basic premises around security is not making sure that it does its function. I mean, that's the functional testing, but the security testing, making sure it doesn't do what it's not intended to perform. And this is a good example of that. All right, cool. All right, Manny, let's go to you. And there have been some open source projects around being able to install your own firmware onto home router devices. And there's some potential advantages to that. And I think my personal opinion is that we're going to have a growth in sort of open platform devices that where your own software can be installed. But I guess we have to be a little careful about that. Can you tell us a bit?
Yeah, so I ran across this story, and it was just interesting because I hadn't seen anything about this, and this goes back a little ways, and I hadn't realized that something had transpired earlier in the year. And I guess what brought it to light now is that this week marked the end of the reply comment period. I'm not exactly sure what that reply comment period is. I guess the FCC has this puts out some sort of policy, and it allows some period of time, right,
yes,
from feedback on it. So this marked the end, and one of the I guess the rulings that they had put out earlier in the year had caused quite a bit of stir, and that was the whole Wi-Fi router and the ability to modify the firmware on it.
So basically the proposal or the draft regulation basically stated that you weren't allowed to change the firmware on a home router device.
Exactly. Yeah. So they just stated, hey, we want to stop folks from, manufacturers from allowing firmwares to be overwritten, and the policy actually stated that they wanted the manufacturers to prove that they had a manner to stop that from actually happening, right? So they wanted that actually to be proof that, hey, look, we're stopping folks from actually being able to overwrite the firmware on our devices. Now, there was a couple caveats to this particular ruling, which was it only affected devices operating in the unibands, or the spectrum used for the 5 gigahertz Wi-Fi. So that limited it down. So again, it caused quite a bit of stir because we all know that there are quite a few open source, DDWRT, Tomato, right? So there's a whole bunch of them that sort of expand the functionality of a router today. And I don't think there's been much in the sense of maliciousness in that overriding. I think it's mostly for just expanding the capabilities of that router. But unfortunately, as we all know, it does open up some things to being abused, let's say. So I think
it's a source code platform, so it would allow anybody to basically modify it in their own way and perhaps load it on the device.
Yeah. On the 12th of November, they issued an update to the ruling saying that they hadn't intended to encourage the prevention of modifications across the board. That what they actually meant was that they wanted to simplify against mods that would take a device out of RF compliance.
Right.
So
the primary concern around all of this was really to make sure that the signal that's coming out of those devices is not going to interfere with other bands, interfere with other devices, be too powerful, that type of thing.
Exactly. And one of the examples that they state in here was that I guess they had seen in some cases, extreme cases I'm assuming, where in airports they could see that it was affecting the Doppler radar, weather radar.
Oh, that would be not so good.
Not so good. Right.
Not so good.
Exactly. Yep. So they came out again and said, hey, look, this is, we didn't intend to put an absolute rule here. This is what we actually intended for this to mean. That we didn't want that modification to allow this. The problem is, though, and I think we talked a little bit about this earlier, was that unfortunately the the chips on the routers today both contain the CPU and the radio on a single chip.
And other things. The system on a chip sometimes has things like USB interfaces, other peripherals.
Right. So unfortunately, what that means is if you don't allow them to modify one thing, you sort of, the way that it's set up today, you sort of can't have it one way and not the other.
Yeah,
so
the hardware controls aren't really there to facilitate controlling one thing, changing firmware for one aspect and not necessarily having impact on
Right,
other
so
aspects
what
of
they're
the
saying
device.
basically is if this policy goes through, we're just going to have to lock it down completely. We're just not going to be allowed anybody to modify. You can't just separate the RF
Well, and then
from the...
until perhaps they come with a next generation device, which might be higher cost, right?
Exactly,
Yeah.
yes.
But you've also got the problem that manufacturers aren't just designing for the US market. So if they're building the same system on a chip-based router for all of their markets, if you have to make that separation, now you've got to add another model to your line that uses a different system on a chip with an external, whatever firmware for controlling the radio.
Yeah.
And that's probably most businesses aren't going to be amenable to that.
It depends on the market.
Yeah.
Depends
I
on the market.
suppose.
And depending on how it's locked down, how does that affect, firmware updates from the manufacturer? We have the problem already where nobody's updating their routers with new firmware anyway, but if there are security vulnerabilities and the manufacturer sends one out, depending on how it's locked down, is that going to make it much more difficult for the user to apply security patches?
Yeah, it's an interesting point, Jim. I was sort of taking an optimistic view that given these constraints that are required, that it might inspire them to do a little better job with the opportunity to update devices. But hey, it could go either way here.
You still might be able to do, if they wanted to do that.
Yeah.
They could still do something with code signing where those updates are legitimate updates only that's signed by the manufacturer.
Right, absolutely. So, I guess just as a point of clarification for folks that might not already be aware, the FCC is basically responsible for allocating spectrum and managing, radio wave spectrum.
Yep.
And I suspect, the 2.4 gigahertz was the typical Wi-Fi in the past. They added 5 gigahertz. Right. It apparently has a little closer proximity to some other things that might get interfered with. Yeah. I don't know if this is exactly true, but my impression was that basically the 2.4 gigahertz originally came out. That was unlicensed spectrum, partly because I think it's the same frequency that microwave ovens work on. And it was considered basically unlicensed experimental space. And a lot of these basically consumer devices started using it, took off, and now they're kind of adding some additional bands to it. They're perhaps even more effective, but then perhaps have closer proximity to other things that could get interference, and it needs to be controlled so that it doesn't. Hence Doppler radar, for example. That would be pretty sensitive stuff if you're trying to bounce signals off of water.
That makes me think a little bit about systems like software-defined radio.
Right.
Know what the restrictions are on that when you've got a system that's designed specifically to start messing around at that lowest level of radio transmission. You could do something, intentionally to mess with Doppler radar using software-defined radio just by building it out in something like new radio.
Right.
So
But that would be illegal.
Yes, it would. No, I agree with you. I'm just saying that there doesn't, at least from what I'm reading or hearing here, is that there doesn't seem to be any sort of provision in this law that says you can't take your software-defined radio and have the exact same effect as modifying a consumer router would have.
Yeah, I think this was perhaps a case where they were trying to control a more broader industry, perhaps, where people might be doing something in a more...
where it might be easier to get your hands on the hardware that allows you to do this? Is that what we're saying? Or?
Well, it's a good question.
Okay.
If
you know the answer
we
to
can
the
only
question,
speculate
please
on the
write it.
motivation for one thing versus the other. But nevertheless, basically changing radio behavior, I think, is already a regulated activity. And I think perhaps what they were doing here was trying to reinforce that in a particular industry area, and trying to make some clarification on what the true intent behind it is. This is a balance area where I think perhaps separating the modules is perhaps the best thing to do if you want to have an open source platform. My hope is that we see more hardware platforms that are open, so that you have the opportunity to do development and create new kinds of functions on these platforms without necessarily the constraints, and perhaps improvements from a security standpoint. Being able to update the software automatically, things like that. So, okay, so Jim, let's go to you. And we always have something on IoT here. This is a little, perhaps not new or different, but certainly intriguing.
Yeah, this one was kind of strange. I happened across it on one blog, and then found some references back to where it originally was published. But there's a group out of Boca Raton, Florida, that they're a company that their job was, they were trying to develop a cloud-based video storage system for government agencies and police departments to store video from body cams. And so they got a bunch of body cams from one particular manufacturer and plugged them into their laptops, and all of a sudden their antivirus went nuts. And what they discovered is that that they had Conficker infections on these body cams. And the first thing that struck me is this reminded me a whole lot of, it must have been 8 or 10 years ago. There were a bunch of USB picture frames that came out that had malware on them, and it looks like something similar happened here. It looks like this manufacturer had an infection in their enterprise, and as they were, setting up these body cams, they got infected with Conficker. They basically had an autorun.inf file placed on the internal storage of the body cam, and when you plug that into a Windows system to download the video off of it, then it gets treated as just a normal external USB device. And if you've got auto runs turned on, then it would attempt to execute this. Conficker is like more than 6 years old now. If you've got up-to-date antivirus, hopefully you'll catch it. But we've been seeing in the internet weather since we started doing this show that it still lives on. So this just got my attention. It's another, how many people would think about, their body cam as being a potential source of infecting their network? But I'm not sure what conclusions to draw from it. I just have to shake my head.
Yeah, this is a particular case. I personally don't wear a body cam, but for the police that are wearing body cams, you would be particularly concerned, I think, about a police department potentially being infected by something like this. So, Jim, what systems would we expect? You mentioned the auto run, but aren't some of the newer systems already kind of protected against in their default configuration against this type of malware?
Yeah, the latest versions of Windows, if it's not the default, it's easy to set to not automatically mount and read and fire up whatever is in the autoruns.inf file on USB devices when you plug them in. But that was a feature in years past, where as soon as you plugged it in, then it would start up whatever, start up the video or install the software just by plugging it in. That's because of cases like Conficker. That is no longer the default, but there are still XP systems out there. So.
Yeah, I think it gives you a prompt to see if you want to execute it, right?
Right. Yeah. The new one is it prompts you, what do you want to do with this? Do you want to run the, the setup, or, fire off the whatever? But you actually made a good point there, though. With police departments and and these body cams, the fact that there's malware on there is kind of scary in a number of ways.
I mean, just the potential exposure of information that isn't supposed to be in the public domain and potentially getting out to a thief or something of that sort. And reminder that we're talking about Conficker here, which is a specific example, but the fact that this kind of an issue occurred, other types of malware could potentially get on these devices and become a propagator for other types of malware that devices are more susceptible to.
Right,
still.
and this batch came, essentially pre-infected. It got infected at the manufacturers, but as I said, when you plug these things in, they're essentially just another USB disk. You're copying the video off of it, and then you're deleting it. Well, if your Windows box is itself infected, there's nothing to stop it from dropping something back on there that, then the next time it gets plugged into a different system, it could infect that.
Well, it's all the better it was discovered, perhaps, hopefully earlier rather than later.
So I have to ask here, because we just brought it up. Whatever happened with the video picture frame? That's seems to be almost a
It's
a
still
dead.
it's
Is
Oh,
it
you
still
know,
alive?
as the hardware?
Yeah, I mean,
think they call it I think they call it a smartphone now.
That's what I'm saying. They timed that a little wrong with the smartphones coming out, and
Yeah.
I think that.
well, it had its little heyday, and then
That's right.
and we've moved on. That's just part of life, right? Jim, since you had the discussion about Conficker, I thought I'd include just a look at the scam probing activity on port 445 TCP, service management block associated with Microsoft devices. This is one of the vectors in which Conficker would propagate. You described another one where it could propagate through a USB device as well. This was the sort of the network vector, and then there was the device vector. But looking back at the last year of activity, we've been tracking this for several years. I think he said it's almost 6 years old now. I think it's actually perhaps more. Wasn't it 2008 when Conficker came out? It was around 2008. Yeah. So I think it's Well, nevertheless, I'll trust your memory before mine. Looking here at the last year of activity, and this is a 10-day moving average that we're looking at. So each hour is actually looking at the previous 10 days and averaging over that. So we get a little smoother curve, less spikiness in the activity. But we see basically a net increase in the amount of scanning activity on this port. Now, this might not be all Conficker. In fact, I'm pretty sure it's not. You can also do password guessing against file shares that are available on the internet through this avenue as well. But nevertheless, there's still an awful lot of probing activity, and a good portion of that is associated with basically the Conficker worm. That and just for folks that are not familiar with this, to our knowledge, this Conficker had never really been used for anything. It did a great job propagating, got everybody nervous about what it was going to be, but and it had some really sophisticated capabilities in terms of command and control, but to our knowledge, had not really ever been used for anything. We feel that, or the belief was that the folks that created this malware were exorbitantly more successful at infecting devices than they expected, created a lot of attention, and basically backed off and said, they probably built a different botnet that was a little more cloaked.
Yeah, our producer tells me that Conficker actually turns 7 this month. It was November
Okay,
of 2008.
there you go.
So happy birthday, Conficker.
Happy birthday. Okay, so just taking a look at a couple of other items here. And I'll show you the difference here. This is just a look at the composite of reflective denial of service attack activity over the last year here. And again, using that 10-day moving average. And just to give you a little bit of comparison, I'll go to the next slide here, which shows without the 10-day moving average. And you see how much spikier this is. It's much more difficult to read. So we're going to get a couple of valuable attributes from both of these. First of all, looking at the primary sources that we see here, port 1900 UDP, that's a simple service discovery protocol. That's basically intended to be a LAN protocol, but a lot of not well-designed home router devices expose that to the internet, and consequently it can be used for reflective attacks. Port 0 UDP is generally associated with fragmented packets, and there are a couple of these protocols that generate fragmented packets. In particular, I think it's Character Generator generates fragmented packets, and I believe, DNS can generate fragmented packets as well. Port 123 UDP, that's Network Time Protocol. That can be used in reflection attacks. There are a lot of devices that are exposing Network Time Protocol to the internet as a server. Almost every device uses it as a client, but it turns out it's actually the same process that runs as a client and a server. If you don't control one or you configure it properly, it will expose both of those. And then DNS, reflective denial of service attacks can be facilitated through DNS servers, and so it's important to try to control. You can't turn DNS off, it needs to be there, but it's important to control who can access recursive servers. And then 1900 UDP, this is Character Generator, and quite frankly, there's not really a good purpose for a Character Generator these days. I mean, it was basically a connectivity test protocol. You send it a request, it sends you back the alphabet and some things, and it can fragment packets, so it'll generate some additional traffic. Some others, Akamai come out with a report recently. They talked about RDP, that's port 111 UDP. We've talked about in a number of programs simple network management protocol, that's 161 UDP, 520 routing information protocol, which is a very basic, basically broadcasts your routes out. There's basically a request function associated with that. Port 137 UDP, that's basically name server associated with Microsoft devices, and that can be used in reflective attacks. And then last but not least is 5093, which is an IBM, I think it's a key manager protocol for software licenses. And I haven't seen too much of that activity here, but nevertheless, let's take a little closer look at the bands here. And these are relatively in order. So at the top of the list, 1900. Next one here is a fragmentation. So the fragmentation would be contributors from DNS and Character Generator. So that's basically these third and fourth bands, the purple and the turquoise here. And then in the middle here we have basically Network Time Protocol. And then at the bottom you can start to see how this is sort of growing a little bit. I probably should have had a blown up image of it, and perhaps the producers can show it a little bit more closely, but we are starting to see some more activity, particularly around 161 UDP. There's some growth there. And we're starting to see, well, I should point out here, since the perhaps the middle of the summer, some significant decrease in 1900 UDP. So a couple observations there. Now, this basically shows, we're measuring this in gigabits per second, so you can see roughly how that shows up on the network. Now, what's worthwhile is to try to look at, this is on an hourly basis, and you can see where things have spiked up. So there's a lot of spiky activity that occurs where particular attacks are larger than others, and some of these, getting upwards around exceeding 40 gigabits per second. Now, the actual attacks are probably much larger. These this analysis doesn't cover the entire internet, obviously, but it gives you some idea of what types of things are going on and relative measurements of that activity. So what we thought we'd do here is a short segment. It's very close, if not just after Thanksgiving when you're viewing this program here, so we wanted to share a little bit about what we are thankful for. And Jim, why don't you go ahead first here?
Okay, thanks, Brian. The first thing I am thankful for is the open source community for providing so many tools. There's not a day that goes by that in my job I don't use, an open source tool, a forensics tool, or a network monitoring tool. So I am thankful to those in the community who do the hard work so that I don't have to reinvent the wheel. Yeah,
that's actually a very good point. I agree with you thoroughly. The open source community really has been going strong. And what I think it's important to remember, the open source community isn't a gift from everywhere. It actually is one where you have an opportunity to contribute to it as well, and that's how it's really pooling of resources, what it comes right down to. So very good point, Jim. I agree with you thoroughly. Matt, let's go to you. What are you thankful for?
Well, I'm thankful for just the sheer amount of open source research that's being done these days in terms of security vulnerabilities, in terms of actor group research.
Mm-hmm.
It's so much to read, and I enjoy every minute of reading it. So to the people who are out there doing this research, thank you. You make my life interesting, and you give us a lot to think on and work with. So thanks.
Yeah. I think generally speaking, in order to be prepared to defend yourself, you really have to have a good understanding of what's going on out in the world. And the research gives us good insights into those types of activities. And not just vulnerabilities, but basically getting a better understanding of the attack campaigns that are taking place, documenting those. It really is a strong contribution. And a lot of the organizations that are generating that, they're in the business of cybersecurity. They're drawing attention to their products, their brands, and showing their capabilities, along those lines. And hopefully it's paying off for them, because it's certainly a value contribution to our understanding of threats and being able to be prepared to protect against them.
Absolutely.
Yep. Manny, what are you thankful for?
So I took a little bit of a different spin on this one, since I didn't think we were going to get so serious on these. So the thing that I'm most thankful for is that the new Star Wars movie is coming out in less than a month. I mean, no, but in all seriousness, what I'm thankful for is our wonderful legal team here at AT&T.
Oh.
Yeah.
I have to appreciate that. I'm going to second that, because the reason we are able to bring this program to the public is because we've gotten a good cooperation from our legal team, our
Absolutely.
public relations team,
Yep.
and I hope that this is a good contribution to the community and that the people appreciate it. We get a lot of good feedback, so very much appreciative for their support in the program.
Absolutely.
And I'm kind of along the same lines here. I'm thankful to be working in an organization that's always trying to sort of push the envelope in terms of the technology and the methods and the capabilities that we have available to us to improve security. And I think that's just it's sort of in the roots, the ancestry of AT&T, and we continue to draw that forward. And I'm also very thankful for the team that you folks that really are the ones that make it happen. So certainly in the threat analysis aspect, there are certainly a lot of other folks in AT&T that contribute in terms of developing technology and implementing it and making it so. So I'm very thankful. So this is a great time of year to be thankful, and we hope that our viewers are thankful for something as well. And we'll be more thankful when the security problems go down next year, right?
I'm sure that they will, Brian.
Yeah, probably not anytime soon. So we're thankful for the job security that the security problems give us.
Right.
That's our show for today. We thank you for joining us. We're thankful that you're here. And if you'd like to get in touch with us, we certainly welcome your feedback. You can email us at attThreatTraq@list.att.com, and you can find AT&T ThreatTraq on the AT&T Tech channel, on YouTube, and on iTunes. You can follow us on Twitter. Our handle is at AT&T Security, at ATT Security. First of all, thank you, Jim. Thank you, Manny. Thank you, Matt. I'm Brian Rexroad. We'll be back next week with a new episode, and until then, keep your network safe.